Let's take a look at lesson 17.4, Investigating Symmetry, final lesson of module 17. This is in module 17, right after our three transformations, our three rigid motions, because it is related to both reflections and rotations. In fact, it makes up both of our types of symmetry. Okay, so let's do one at a time here. Our first one is called line symmetry, also called reflectional symmetry. If we can draw a line through a shape, and the example that you see below here, it actually has one line of symmetry just going down the middle, okay, like so. We call that a line of symmetry. So there are shapes that have one line of symmetry, there are shapes that have no lines of symmetry, and there are some shapes that have more than one line of symmetry. And as long as it has one, it has what's called line symmetry. So let's try a couple of these. On page 872, up at the top, let's look at these three shapes. So first one we have is a rectangle. Now it's important you know what these marks mean because you're going to start seeing this a lot more often. This little block at the corner here means that it is a 90-degree angle or a right angle. Okay, same thing. This little mark right here means that it is same length as this one because they both have one mark, which also means that this would have the same length as this one because they both have two marks. Okay, keep that in mind. The same length, we also call that congruent. So we have two pairs of congruent sides. So thinking about line symmetry this time, we want to think about where could we draw some lines so that it has symmetry, meaning if I folded it over the line, would it match up perfectly with the other side? Okay, so here are some obvious ones that many students come up with. That one is a line of symmetry because if you fold one side onto the other, or vice versa, it matches up perfectly. And the same thing is this other one here going straight across. Okay, that one right there. Because if I take the top part of the rectangle and fold it down to the bottom or the bottom up to the top, they both match up perfectly. And I want to show this one, but it is not a line of symmetry, but it's one that's often come up with, is this one right here going across the diagonal. This is not a line of symmetry. If you took a piece of paper and you folded it in half, this same exact way along the diagonal, you'll see that it won't overlap. Once one side won't overlap the other side perfectly, there will be some overlap kind of hanging off. So it is not truly symmetrical on the diagonal. So I'm going to erase that. This means that we only have two lines of symmetry. The next two shapes, this is going to be one of the biggest challenges in geometry. There's no information given to us as to what's congruent or what is the same measure, like what angles have the same measure, what sides have the same measure of length. So we're going to say in the second one, there are no lines of symmetry. There's no way you can cut this thing in half. It is very possible, because students come up with this, that this side or this line of symmetry right here, I didn't draw it perfectly, but from the corner to the midpoint of this side, looks like it could cut it in half. But that only works if this side is congruent to this side. And I don't believe it is exactly equal. I think one is slightly longer than the other. You can go and measure it with the ruler just to test it for yourself, but it's not equal, so therefore it's there's no lines of symmetry. And with this L shape, this one's also an iffy one for me. but you can measure everything. I believe they are all equal to each other, the ones that needed to be. So if that side is equal to that side in measure, if this side's equal to this side right here is equal to this side. Okay, see, notice the amount of marks I'm having to use. Then there is a line of symmetry that's going to be coming from that bottom here and going up this way. By the way, drawing these lines of symmetry is a way of you showing your work and showing your thinking. So please make sure you include that when you write down how many lines, because sometimes you might miss one, right? Or sometimes you come up with one that isn't really a line of symmetry, but you come up with all the other ones. So it's important that you draw those. So that last one has one line of symmetry. Moving on to the next type of symmetry, rotational symmetry, which means we're going to be rotating a figure around the center of the figure, and we want to get the same exact image. So if you're thinking about rotating this star right here, we're going to pick the center somewhere in the middle here. I can show this a lot easier on a transparency. I'm not going to be using any tricks here to show you this thing rotating. But if you were to rotate that, rotate this tip right here so it matches up here, right? It would look exactly the same. We're not worried about what points each thing is, points A, B, C, D, E, F, and so on. We're just going to ignore the points. And how do I get the same exact shape without having to go 360 degrees? I want to go less than 360. And if so, and if I get the same pre-image, then it has rotational symmetry. Depending on how many degrees I turn it, that's going to be our angle of rotational symmetry. Okay, so let's just look at a few of these shapes. At the top of page 873, we have what looks like a square. And I don't know why they didn't put it there, but you go ahead and add this mark. This is a square. We can actually rotate this thing so that that point goes over to this point, right? And this one goes here, and so on. So this does have rotational symmetry. It can rotate 90 degrees and be the same exact looking square. And also 180, right? That's just the second time. And then finally 270 degrees. We're not going to write down 360 just because every single shape rotates 360 to get the same thing. So you don't have to write those down. The next shape, the triangle, is not going to have any rotational symmetry. We cannot rotate this thing at all. Again, I highly recommend you use a transparency. It's nice to see that visually, you turning it. Come in and see me if you're not sure exactly how to set that up. And the last one, you have to make some assumptions here. I don't really like doing that, but taking this part of the arrow and rotating it halfway around in a circle, right, if that's a full circle, is going to put the top arrow down here and then the bottom arrow up to the top. So this thing looks like it does have 180 degree angle of rotation. So it does have rotational symmetry. Let's go all the way to page 875. This is going to be the last part of our lesson where we kind of put the two types of symmetry together. So I'll do a couple of these. I would like you to pause it and try the other two. Number 6, it looks like we have another square again, and we did the angles of rotation already for that, so I'm just going to write those down. That is 90 degrees, 180 degrees, and 270. Now the lines of symmetry, I'm actually going to draw them on there, are straight up and down, straight across, there's one going down this way. I'm not drawing these perfectly because I'm just using my line tool here to do this for me. But it doesn't look too bad. Looks like those are our lines of symmetry to cut this thing in half so it's matched on both sides. So there are 4 lines of symmetry. And since it has lines of symmetry and it has angles of rotation, it has line symmetry and rotational symmetry. So that's what it refers to by the types of symmetry. Number 7, the lines of symmetry. I don't know why it has this drawn for you, but it is this line right here. That's our line of symmetry going through G there. And that's it. So there's just one. And then angle of rotation, this actually does not have any, so we're going to put none. There are no angles of rotation, and therefore it only has line symmetry, just that type. Go ahead and try 8 and 9. The solutions will show up here in a few seconds. Number 8 has only rotational symmetry, and it has these degrees down here, 72 degrees, 144, 216, 288. If you're to do this on a transparency, if you rotated it so that this part right here matches up with this part, then think about how many more times you can do that so you get the same figure. So if that's one time, then if you took that and went again, and that and went again to the other corner, and again to the other corner, and again to the other corner. That's 5 times to go all the way around. So you're taking 360 degrees and you're dividing it by 5 times because you're assuming that you're going the exact same number of degrees going around in a circle. Okay. For the lines of symmetry, this one is really, really tricky, but it's mainly because of that extra piece. So I'm talking about this piece that's in purple here. These pieces, actually, it's on every single corner. The way it's drawn, we have rotational symmetry, but if you were to draw a one of the easier ones, or at least one of the common lines of symmetry that students come up with, is this blue one right here down the center. If you took this right side and tried to reflect it over to this side and see if it matched up, you would see that it didn't, because this piece is going to reflect right here and there's nothing there. This piece is going to reflect down here and there's nothing there. You see the pieces up top, not at the bottom, and so on. So very, very, very detailed, but this, because of that, there is no line symmetry at all. And number 9, this is easy to see for most, but there are no types of symmetry because we have no lines of symmetry and no angles of rotation. There's no way that we would just get the same thing if we reflected or rotated it. It's a good idea to understand all 4 of these problems because these are the 4 different situations that you're going to come across where you have a shape that has both line symmetry and rotational symmetry. This one right here has just line symmetry. Number 8 only has rotational, and number 9 doesn't have any of them. Okay, so sometimes you might be asked to come up with some shapes that have one of them or both of them or none of them.